download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about Group 1 elements. Now, Group 1 metals are all very reactive. And that is because in Group 1, they all only have one electron in their outer shell. And because it's easier to lose one electron than it is to lose 2 or 3, this makes them very reactive. They're readily available to react, i.e. they are reactive. And they're all quite soft metals. Okay, now you may remember doing the reactions with the alkali metals and water in your lessons, and you will remember that your teacher should have just been able to cut these with a knife because they're all quite soft metals and they're all very reactive. Okay, now the Group 1 elements are lithium, sodium, potassium, rubidium, cesium and francium. So they are the Group 1 elements, and as I said, they all have one electron in their outer shell. Now you do need to learn and remember some trends that happen as you go down the group. Okay, now the first one is as you go down the group, they have a higher relative atomic mass. This can just be seen by looking at the periodic table. So the mass of lithium is 7, and sodium is 23, and potassium is 39, rubidium is 85, cesium is 133, and francium is 223. So as you can see, the mass gets higher as you go down the group. That is really just because the atoms get bigger. They have more protons and more neutrons as you go down the group. Now, as well as this, they have lower melting and boiling points as you go down the group. So as you go down the group, their melting and boiling points are actually lower. This means that francium has a lower melting and boiling point than lithium, and francium has a lower melting and boiling point than cesium, as they get lower as you go down the group. And the final one, and probably the most important one, is that they get more reactive as you go down the group. So more reactive as you go down the group, which means that francium at the bottom is the most reactive and lithium is the least reactive. Okay, so you should maybe remember that practical where your teacher dropped one of these alkali metals into water, and with lithium you saw some light fizzing. Sodium, it would have fizzed a bit more vigorously, potentially producing a little flame, and then potassium producing a flame and bubbling and fizzing much more rigorously. This shows that obviously potassium is more reactive than lithium. But francium, obviously you wouldn't have been able to do at school, nor cesium nor rubidium, but they are much, much more reactive than lithium, sodium and potassium. Now, just to very quickly explain why that is, let's first just rub these out. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. I'm going to draw their electronic configuration. So lithium has 3 electrons. Therefore, we draw the electronic configuration like this. And sodium has 11 electrons. Therefore, we draw the electronic configuration like this. And if you don't know what I'm doing here, then I would suggest please go and watch the electronic configurations video to really help you out, because that would be very important. Now, as you can see, they both have 1 electron on the outer shell, and it is their job to gain a full outer shell to lose this electron. Now, you'll remember that electrons are negatively charged. They are negatively charged particles, and the nucleus contains a positively charged protons and neutrally charged neutrons, but the main thing is that the nucleus is overall positive. That means that these electrons are attracted to the nucleus. They are attracted to that positive pull of the nucleus because they're negative, and positive and negative attract. But if you look at sodium, which is here, their negatively charged electron in the outer shell is further away from the positive attraction of the nucleus, and therefore it's a weaker attraction, so it's easier to lose this electron. Whereas lithium, which is here, is closer, the outer electron, the negative, is closer to the positive nucleus, and therefore it is a much stronger force of attraction, which makes it harder to lose this electron. And that is why sodium is more reactive than lithium, because in sodium it's easier to lose the outer shell of electron because it's further away from the nucleus. And as we go down, the atoms get bigger, and therefore the outer shelled electrons get further and further away. So therefore it gets easier and easier and easier to lose that electron the further you go down the group. And that's why it's more reactive as you go down group 1. Now, as I just was talking about earlier, you should or maybe remember the reaction with water, your teacher reacting these alkali metals with water. And as you go further down the group, they start to react more vigorously. So lithium, sodium and potassium, they float and move around the surface, fizzing furiously. And the important thing is that what you may have noticed when doing this is you or your friends or people in your class may have started to cough a little bit. And that is because when you react an alkali metal with water, you are producing hydrogen gas. Okay, so you're as well as producing hydrogen gas, you're also producing a metal hydroxide. So let's write what you should have then. So it's an alkali metal, and you're reacting it with water, and what will be produced is a metal hydroxide and hydrogen. So for example, if we were to react potassium with water, what we would get is the metal hydroxide, but the metal is potassium, so it would be potassium hydroxide plus hydrogen. Okay, and just one more quick example. If we were to react lithium with water, we'd get lithium hydroxide plus hydrogen. Okay, so it's always a metal hydroxide plus hydrogen. Now you may also need to produce the equations and a balanced equation for this. So potassium is K plus water is H2O, and that produces potassium hydroxide. Now a hydroxide is something OH, so it's potassium hydroxide, which is K, so it's KOH, and hydrogen gas is always H2. Okay, now you can see that that's not balanced, so to balance that equation we would need to do, so we've got two hydrogens over here, we've got two and only three hydrogens over here, sorry. So what we need to do, we need to put a 2 in front of this to make 4 hydrogens, and therefore we'd also need a 2 in front of this and a 2 in front of this. Now if you don't know how I just did that, then please watch the balancing equations video to help you out. It's the same with lithium, so lithium being Li plus H2O to give Li hydroxide, which is LiOH, plus hydrogen H2, and it's the same in terms of balancing. Okay, so they are balanced equations for our reactions with water. So what we need to be aware of is when we react an alkali metal with water, we're getting a metal hydroxide and hydrogen. Remember, a hydroxide ends in OH for when if you are asked to balance a symbol equation. Now alkali metals also react with chlorine and they produce a salt. And the name of that salt depends on the name of the alkali metal. So let me explain. If we were, for example, were to have sodium and we mixed it with chlorine, what we would produce is sodium chloride. And that is a salt. Okay, so let's go through another example. Again, if we were to have potassium and we added that to chlorine, what would be produced would be potassium chloride. And in terms of our equations for this, Okay, sodium is Na. If we were asked to do it right, a simple equation. Chlorine gas is Cl2. And sodium and chlorine are NaCl, which means we'd need 2 lots and 2 lots to balance those equations. And please, if you don't know how to balance the equation, go and watch the balancing equation video, and I'll tell you how to do it. Potassium chloride were the same, so potassium is K plus chlorine gas, which is 2. We'll make potassium chloride. We need 2 lots and 2 lots to balance the equation. Now, because alkali metals are very reactive, they also react with oxygen to form a metal oxide. And again, that metal oxide really does depend on which metal you are adding to oxygen. So, for example, if we had lithium and added it to oxygen, we would produce lithium oxide. And if we were to have rubidium and we added it to oxygen, we would have rubidium oxide. Okay, so reaction with oxygen, they always produce a metal oxide, and that metal oxide depends on which alkali metal you are reacting. So now what I'd like you to have to do is answer these questions here, and then we'll run through the answers together. So pause the video now. Okay, so number 1, what happens to the reactivity as you go down the group? Well, it increases. The reactivity increases as you go down group 1. What happens to the boiling points as you go down the group? They decrease, or they get lower. So as you go down the group, the boiling points get lower or they decrease. What 2 products are formed when an alkali metal reacts with water? Well, you have a metal hydroxide plus hydrogen. What does the reaction of a group 1 element make with chlorine? It makes a salt, or a metal chloride, which is a salt, of course. And finally, write the word equation for the reaction of potassium with water. So we got potassium plus water, make potassium hydroxide plus hydrogen gas. So we've now learnt about group 1 elements, we've learnt about their patterns as you go down the group, we've learnt how they react with water, chlorine and oxygen. You can now move on to the quiz and test yourself using the exam questions to really make sure you understand. And if there's anything you do not understand in the video, then please do get in contact with one of our tutors who will be happy to help.